Yeah, part of it, I had a hard time even getting the sequence to work because it didn't want to recognize what I was.
That's a 7-minute drive from my
I did it one time horizontal.
There was 4 questions.
That wasn't the smartest idea. I have 2 versions.
The lights off on the screen.
Yeah.
True.
All set?
Yep.
Anything?
So should be good.
Okay, looks like everyone's here. So, we'll take it away.
Alrighty, we're gonna get started. Any of you guys play around with GeoGebra a little bit since last time? A little bit. Okay. Good. So I don't really remember where I left off last time, so I'll just start somewhere. Again, as always, ask questions as they pop into your head. Stop me whenever, that's fine. I'm going to try to get through another handful of useful features of GeoGebra today. Of course, I won't cover everything. It'll take a long time to cover everything. But so we're going to start. We talked a little bit about sequences at the end last time. So in GeoGebra sees sequences basically as a list, like an iterated list, but you can also create your own lists, and they don't have to be sequences. So I'm going to show you guys something. I was going to end with this, but I think I'm going to start with it because it's kind of a nice feature of GeoGebra. So you can create lists, so maybe I'll just name my list funcs. I can create a list just by doing, I don't know if you can see that very well, but those are just curly braces. So next to your P button, shift square brace, your curly braces, it'll start your list, and then you can start typing things in. So if I do something like, I'm going to do a list of expressions in x, so I could do like x squared, x cubed, x to the 4th, maybe cosine x, and tangent of x. So when you hit enter, GeoGebra is going to see this as a list of 5 different objects, basically. It won't plot them, it's just holding these 5 things in one list. So what I'm going to end up doing is having a slider that will control which one of these expressions I'll graph on the screen. So I have like a slider, and as you increase the slider, it's going to show the graph of different functions on the screen. And this is a really nice, easy way to do that, and you can do a few different cool things with this. So now what I'm going to do is going to create a slider, and like I said, I want my slider to go right now from 1 to 5. So however many things are in this list, I want to go from 1 to however many are in the list, so that my slider will go through each element in this list. So what I'm going to do is I'm just going to name my slider n. I'm going to use my slider command. Now I'm going to start at 1. So I'll start with 1. And we want to end at 5, so we'll go 5. And we'll go in increments of 1. So if I enter that in, it'll put a slider on the screen. Goes, and I must have screwed that up. So I want my increment to be 1.
That happened to me too yesterday.
Sometimes, I don't know why it does that. Sometimes it'll just not recognize it. So if that happens and it doesn't recognize your increment, you can just go to the object properties, and there's like a whole tab for the slider properties, and you can change like the start, the end, increment, various other aspects of it there. So if it, for whatever reason, it doesn't actually do the increments you want it to, just go to the object properties and change there. So now what I can do is define a function. I'm going to call this, I'll just call it f of x. What I want it to do is, if n is equal to 1, I want f of x to be equal to x squared. If n is equal to 2, I want it to be x cubed, so on and so forth. So really what I want to do is like pull these things from this list that I have. GeoGebra has a built-in command. It's called element. So if you start typing ELE element, it'll give you some options. And the first one is list and position of the element in the list. So if I tell it I want to pull from the funcs list, and I want to choose the nth element, I'll just do my list name, and then I'm going to use n as the element I'm choosing. When you hit enter, it's going to create this function f. Right now it's x squared, but if you change your slider, f of x is actually going to change. So this is an easy way to do, like if you have a bunch of different functions you want to show, you don't have to like create a bunch of different ones. You can just like have one master function and control it with a slider. Another thing which is really, really useful, so I have this slider up here. Right now I have it going from 1 to 5, but maybe later I want to add like 18 more functions in there for some crazy reason. Maybe, and now I want my max to be 23, not 5. So what you can do is actually tell it, I want the ending value to be the length of the list. So GeoGebra has a command called length. And so I can call length, and I'm going to do of the list funcs. When I hit enter, it's going to recognize that, and it's still going to go from n equals 1 to 5. The ending value is now the length of whatever this list is. Yeah?
What would happen if you made it a value that was larger than the list? Like your list has 5 elements in it. If you made it 6, yeah, if you made it like 6, and then you tried to go to 6, what would happen? It would just not graph anything?
Yeah, so what it's going to do is, I just tried it right there, so G is trying to pull the 6th element from this list. You'll notice that it says G is undefined. So it's not going to do anything, it's just going to say the function is undefined, which basically means it just doesn't recognize it, it's not going to show it, it won't use it for any other purposes. So yeah, it just won't recognize it, it'll say, GeoGebra basically says, I don't know what you're trying to do. I don't have that. So now I'll show you like really how you could use this. So I'm just going to add a few more in. X plus 1, x plus 2, x plus 3, cosine of x, a sine of x. So now you notice that now my slider doesn't just go to 5, it goes all the way up to 11. Yeah?
How did you do that part again where you like changed your max? What did you type in there?
Okay, so what I did was I right-clicked on my slider, and I went to Object Properties, and then there's a Slider tab. And the max is going to be like the ending value of the slider. And I realize you can't really see this, but it's length, capital, and then square brackets, and then you insert the name of the list you want to get the length of.
Thank you.
Yep. So now you notice I can display, right now I can show 11 different functions at once. This is actually a really convenient, especially when you start to create other things relative to this one function. So maybe you wanted to like show the area under the curve or something like that. Instead of creating a bunch of different things for each function you have, you just do it all relative to the function f. And then when you change your slider, it's going to change accordingly. So here's like a simple example of that. I'm just going to create a list of, or a sequence of points. We'll just say I, f of I from 1 to 10. So we have this list of points on here. The nice thing is as I change my slider, all these points are going to be relative to whatever function I'm showing, whatever the value of f of x is. So I've found this really useful in a lot of things I do. If you're going to display more than one function at some point, or use more than one function at some point, but they're used for the same thing, sometimes it's really nice to just kind of create a bunch of different ones in this list and then have what I call like a master function, what I'm calling f. Yeah.
Can you make like a sequence of segments?
Yes. So with the sequence command, so I'm just going to call another one, you can really create a sequence of whatever you want. So like you could do a sequence of segments, you could do a sequence of circles, a sequence of sequences. You can create sequences of a bunch of different things. So all you would really have to do is, maybe I'll just do circles because it'll be easier for me to do. You just start to type circle, decide where you want the center to be. So in this case, I, f of I, and we'll just make them all with a radius of 1. I noticed that, it kind of gets hard to read after a while because you have a lot of things going on in your input bar. But you really just your first expression that you feed into the sequence command can be any expression. So you could do like you just have to do the segment command, or if you wanted a sequence of circles, you just do the circle command. Whatever your normal commands would be, you can just feed that into a sequence, and then you'll get a bunch of circles.
Would it be easy to just do like circle of the first sequence? Or is there a reason that you had to type everything out? You know what I'm trying to ask?
Oh, so like if I did circle and then entered in SEQ,
And fabric?
it's not going to work. So GeoGebra is really the way it's programmed. It's only going to recognize circle if the first thing you feed it is a point, like it's the first thing. So the other one's a sequence of points, and so it doesn't really know what to do with it. It doesn't interpret it the way we do. So you do kind of have to be aware of like what GeoGebra accepts as input for various things. So yeah, unfortunately not quite. Sometimes you can get away with doing things like that. Other times you can't. And if you can, it's going to tell you, it'll pop up a little error window.
Going over the sequence of circles was one more.
Yep, absolutely. So all I did here was, so I think this is used in both of the little homework activities that I showed you guys, is creating sequences. In that case, you're going to be doing sequences of segments, but kind of the same idea.
Do you want us to email those into you?
I don't know. I'll let you know at the end. Actually, I'll have to ask Mark what he wants. You might email them to him or me. I'm not sure. I'll find out and let you guys know. All right, you guys, everybody have that? Might be hard to read because my screen is kind of small and there's a lot of parentheses. So this is another kind of, although the lists are not quite the same as sequences, they're not as iterative, I suppose. The list can be really, really handy if you have a lot of things that are similar. You can just start to use, like create a big list and then use the element command to pull elements from a list. And you can also find the length of the list, various things like this. What's that? Oh, okay. You want this back up? You guys got it, or you want me to leave that up there for a little bit? Okay. So I'll space these out a little bit so you can read it better.
You did the one with the points again. You choose inflated points, many points, or it's just
Say that again, the sequence of points.
yeah.
So all I did was sequence and then parentheses I, comma, f of I,
Oh,
and then comma I, 1, 10. So yeah, so it's really just as easy as doing the round braces. Need a little more time, or can I close this out? All right, so we'll keep moving, and if you guys want me to pull that up later, I can. Because I know the sequence like syntax is a little confusing at first. So I'm going to open up a new window just so I can start fresh. There's a few other things real quick that I think are handy, just basic commands. If you have a point on the screen, any point, I guess it doesn't even have to be on the screen, any point, there's a couple functions built in GeoGebra titled X and Y. and z. So if you have points, you could probably guess that your best guess would be that it's going to pull the x coordinate of the point, y coordinate of the point, and that is what it does. So if you type something like, I'm just going to do XVal equals x of a. So this function is just x round parenthesis a, and you might be able to do square brackets as well. What it's going to do is pull the x coordinate of this point A. So if you watch this number over here, this number is always going to be the x coordinate of the point. So as you move the point on the screen, it's going to pull the x coordinate of the point. You can also do the y coordinate of that point. You just do y of a. If you have a point in 3D, you just do z of a, and it's going to pull the x, y, z coordinates for you, which is really convenient for a lot of things I've found.
Like, how do you create x value?
So the command for it is, here I just define a number, but you just do x, like it's basically like a function x of the point A. Oh no, okay. Yeah, so x round braces A. It'll give you the x value of a point. So any point you have, can feed back the x coordinate for you. All right, so another thing, a lot of what I do is like pre-calculus, algebra type stuff with GeoGebra, but I know that a lot of you guys will probably end up teaching geometry at some point, and I think GeoGebra generated out of being like a geometry software. So I'll just talk about some of the basic geometry stuff you can do with it, not too much because I've never actually taught geometry with it. But along with like creating circles and lines, and there's options to do things like reflection about points and circles. There's like intersect commands. If you look up here, you can do like angle bisectors, tangent lines. There's a lot of built-in geometry functions you can do with these, and a lot of these you can even do it kind of like, if you've ever used Geometry or Sketchpad, kind of a similar setup where you have like click and point type tools. So there's a lot of these built in. Honestly, I haven't used those too much. One of the things I do use a lot is different geometric transformations. So like rotations, translations, dilations. I think there's maybe another one or two transformations you can do in there. But these are kind of basic, and you probably use them quite a bit in geometry. You can start to rotate things around the screen. So I have my point here. What I can do is, maybe I'll say, I'm going to create another point. I'm going to call it B. I'm just going to rotate the point A. I'm going to make B so that it's a point, which is the rotation of A. So you'll notice my first option is either an object and an angle, or you can do object angle point, which means you're going to rotate some object by some angle centered at some point, so around some point. So does everybody understand what's going on? What I'm going to do is I'm going to take A, I'm going to rotate it by some number of degrees, or radians actually, about some point, which is the center of rotation. What I'm going to do is A, and maybe we'll just say pi over 2. I'm going to rotate A by pi over 2. And our point of rotation, I'll just take as the origin for now. So what I just did was created this point B. Just by definition, it's the rotation of A by pi over 2 about the origin. So now as you move A, B is always going to change. So that's the rotation of A about the origin. So there's a lot of really cool things you can do with this. So for example, if I won't go too far into it. I'll just leave it at that, and we can play with it more if we want to. Another thing you can do is translations, which is kind of nice. So basically you can create, I'm just going to create a third point C. What I'm going to do is just going to make C so that it's just A but shifted maybe to the right 2 and up 2. So I can say C is going to be, there's a command called translate. Our options are translate an object by a vector, or a vector and a start point. What I'm going to do is just translate an entire object. So I'm going to translate A, and my translation vector is going to be, if I want to shift A to the right 2 and up 2, what's my translation vector going to be? 2, 2. Yeah, so now A is really, we can move A, and C is always 2 units shifted right, 2 units up. B is always the rotation of A about the origin by pi over 2. So you can do some pretty interesting things with those. One of the things I like to do is if you have, I've done this like with like a Ferris wheel animation. Like if you have like 5 legs on your Ferris wheel, sometimes it's a real big pain. Like creating, maybe you had 20 legs on it, or 20 arms is probably what they call it. Instead of creating 20 different segments, you can do like one segment and just rotate it. Create a sequence of rotated segments about A. Yeah.
So would that be like the vector translation that I just showed before that? Or how would you do that?
How do we do that? So let's do it, actually. I think this is a good activity. So I'm just going to delete everything but this point A. So now I just have this point A, and I can drag it around. First what I'm going to do is I'm just going to create a segment. So I'll just title it seg equals segment. What I'm going to do is create a segment that starts at A and just goes to the right. We'll just say 3 units. So if I want to do that, what do I need to tell GeoGebra to do? Create a segment. If the start point is A of this segment, what is our end point? Okay. So translate A by,
How much did you say?
we'll just go 3 units.
Right?
Yeah. Yeah, so that's a good use of that. I mean, I usually do something like A plus parentheses 3, 0. You can add points together. So I actually kind of like this way a little better, but I'll show you another way to do this. So you can either use translate, or you can do something like A plus 3, 0. So GeoGebra will add points point-wise, so it's going to take x value of A plus 3, and then the y value is going to be the y value of A plus 0. So you can add points. It's really, adding points is really just translating a point, so it's really doing the same exact thing. But you can actually shorten up the syntax a little bit. So they produce the same exact thing, but just know that you can actually add points together. You can do things like A minus 3, 0, a lot of things like this. So now I have my point A, and I have my segment on it. Maybe I want to now create, I want it to have 8 segments, like equally spaced, centered at A, about A. So we're creating kind of like a Ferris wheel looking thing with 8 arms. So what we could do is, maybe I'll just call this sequence arms. So we're going to create a sequence. And each element in the sequence is going to be a segment, right? So we want it to be a sequence of segments. We're going to form each of these segments using rotations of this first segment. So there's kind of a lot going on here, but so what we're going to do is each segment is going to be defined by a rotation. So I'm going to rotate. What do we want to rotate? Seg? Yeah, so we'll rotate seg. Now, we need to choose the angle we want to rotate this segment. 2 pi divided by 8. And then center of rotation should be A. Now we also need to tell GeoGebra what we want our variable to be. So we'll say I. And we'll go from 1 to 8. So this is what we get. We didn't put an I in there, right? Yeah, so really, GeoGebra sometimes simplifies things. So this was 2 pi over 8. So this is really creating 8 segments, but they're all the same because we didn't add I anywhere in there. So if you do I times that, hit OK, you're going to create this guy with 8 arms on it. So then you can start to do things like if you created a slider called n, and maybe you let n go from 1 to 50 in units of 1, then you could go in and define this sequence of arms by I times 2 pi divided by n. I don't know what, something went wrong there. Oh, there we go. Got to go to n. Yeah, so you can, yeah, so it's really just creating more and more arms. So there's always going to be n equally spaced segments coming off this center point. This whole thing's going to move with the point A. You can increase the number of arms. Makes it really easy to add a lot of things onto the screen.
Could you make it so like the angle stays the same but starting from a different position? So like if you changed n, it would look like it's turning.
Yeah, I bet we could do that. So you want this guy to start, like the angle, starting angle to be relative to n. Or do you just want to make the whole thing spin? One thing we could do is create another slider and have this whole thing rotating. So this is maybe more like a Ferris wheel. So if I created a slider from 0 to 2 pi, I'm going super fast and I apologize. I'll come back and answer questions here in a little bit because I'm sure I left some people behind. So now we have a slider t. What you can do is define the segment relative to t. So what you can do is have a segment that starts at A. What we really want the ending point to be is to be this point that's circling around a circle of radius 3. Does everybody imagine what I'm seeing? What we're going to do is redefine this black segment, and we want the ending point to be a point that's on the circle. And it's rotating t radians. So for the sake of time, you can do something like 3 times cosine of t. I'm sure this looks familiar to you guys anyways. 3 times cosine of t, 3 times sine of t. It's really just you're going to go A, and then you're going to go to the right, 3 cosine of t. You're going to go up 3 sine of t. Now this guy's going to rotate. So if you animated the slider t, now you have a whatever you want to call that thing. And you can increase number of arms. Maybe you only want 9 of them. And everything moves with A. Cool? I went super, huh?
Show us how to do that again.
Yes, that was super fast. You want me to start totally from scratch, or did you have any questions in particular?
I got doing the 8 arms, and
Okay.
then I got lost.
Okay.
So what did we do with the end slide?
Yeah, that's a good question. We'll start there. So actually, no, let's start with this guy first. We'll start with this segment that I called seg, which is like our initial segment that we're going to use to rotate a bunch of times. And what we decided we wanted to do, and you might need your T slider defined first if you haven't done that yet. So we decided that we want this initial segment to be rotating around a circle. So we're going to start at A, and we're going to end at A plus 3 cosine t, 3 sine of t. Does anybody need me to go back any further? I did create a slider t in there somewhere, so if you're going to replicate this, you'll need the slider as well. All right, so now if I hit OK, I'm just gonna like turn most of the arms off. Now this is what I wanted to do. I wanted to have this initial segment so that it'll rotate around the point A. So it's like sweeping out a circle. All right, so everybody have this? All right, so now what we wanted to do was to create, we have the slider N, and N just controls the number of arms coming off of this guy. So if we go into define this sequence, this is what we ended up having to do. There's a lot of words there, so I'll break it down a little bit. So first of all, we know that we want a sequence. We want a sequence of segments. So we call sequence. We're going to tell GeoGebra we want a sequence of something. And we know that we want a bunch of arms, but first we'll worry about how many we want and what we want our variable to be. So we're going to tell GeoGebra, I'm going to use the variable I as my index or my variable for this sequence. I'm going to start at 1. I'm going to end at capital N, which is going to give us N, whatever we tell it to give us, N things. So then you need to tell GeoGebra what it is that you want it to be a sequence of.
How do you make pi?
Type PI, and then when you hit enter, it should convert it to the symbol.
Sometimes it doesn't recognize me. I have that.
Interesting.
Yeah. I was like, create a slider for PI, and I was like,
I have not run into that issue, but that's good to know. Really?
It's really weird.
Interesting.
The other thing too is sometimes when you do the sequences, it doesn't want to recognize what I is unless you put I after something else. So like when I did it as the point B times I, it didn't like it, but then when I did I times B,
Really?
or the other way around, it was the weirdest thing.
Yeah, sometimes if you have issues, sometimes I like to do like the shift 8, like the little asterisk for multiplication. So sometimes if it reads BI and there's no space there, it'll read it as like a one word, but oh really?
But still, it was like,
Yeah, I don't know.
it was weird.
Did you capital pi or lowercase pi?
Lowercase pi.
So then this rotate command is going to rotate the segment, and it's going to rotate it by this angle, 2 pi divided by capital N times I, and we're going to have center of rotation point A. All right, so everybody have that typed in? Does everybody have their cool little Ferris wheel running? Did that clear up any questions? I'm sure there's still more questions. Yeah.
Do we have to define I anywhere? Is it an automatic index variable?
Well, I is right here is where we defined it.
Okay.
So, like in the sequence.
Yeah.
So you have to tell it what I is. So we could have changed that to like J, and then you just have to use J in your expression. So like, for example, if I changed the, and you guys don't have to do this, but if you changed that to J in the sequence, you would just have to change whatever index variable you're using to J. So you can use whatever variable you want. I is just a common one to choose in various reasons. But the I is, you really actually do define it when you feed it that I in the sequence command.
Okay. And then the 1 is the increment.
1 is the start.
Is the start. N is the increment.
N is the end. And then if you wanted an increment, you just add another one, like you could do like 0.5, something like that. So yeah, right now it's just, this is the variable. We start at 1, end at N.
Where's that? But like, oh, it's that. I don't have it. Slider here actually.
All right, so that was a pretty fast preview of what you can do with these things. Now you can even operate on like these sequences. So you could take that sequence of arms and like rotate that sequence about the origin, rotate that sequence of segments across something else, or translate it. So you can start. There's a lot you can do with translations, rotations, sequences, and this is just one example of how you could do that. So one thing I've done with this is like Ferris wheel problems with like a person riding on a Ferris wheel relative to trigonometry. I've done this to create like an arbitrary number of arms on it, so I could do 8 arms or 15 arms, and then it'll create all the arms, but it also create all the little buckets too, which saves a lot of time. And another nice thing about this is the sequence is really just one object, and so this can be a pro or a con. If you change the color or various aspects of the sequence, it's going to do it for each object in that sequence. But there's no way to change like the individual elements. So it's, relative to what you want it to be. But if you wanted them all to be red, then you just change the sequence to be the color red.
How did you make it rotate again?
So I had this slider T, and my initial segment was defined in terms of T. So this was the definition of my original segment. Yeah.
Can you call that whole entire thing something?
Like, give it a name?
Yeah.
Yeah. So I actually called it arms. Is that what you meant? Or
While it also rotates. That whole like functions, all those functions together, can you name it something else? Or name it?
Well, so it is named arms, and it stays that name.
Like what I'm trying to do is like making like 2 wheels, and to go slide on the x-axis.
Yeah. So right now, if you called arms, or I guess if you wanted to do that, you could just rotate the center point as well. So like if you created a couple of those and they're relative to wherever this center point A is. So like right now, if you had that rotating and you moved A, then the entire thing would move as well. Yeah. All right, so we can come back to this later, but I'm going to keep moving on so that I can cover at least a few more things. Another really useful, if I talked about this on Tuesday, stop me and let me know, and maybe I did. There's things called input boxes. So if I define a number, I'm just going to call it A, and I'm going to define it to be like 2. There's input boxes you can put on the screen, which you can get it from this little toolbar up here, the same one the slider's in, thing called input box. If you click on the screen anywhere, it'll pull up a little box and it asks you what you want the caption to be. And I'm going to say A equals. Then there's a little drop down that says linked object. So what this is going to do is it's going to, in this input box, it's going to put whatever the value of the object is that you choose, And if you enter something into that box, it's going to update the value of the object. So I'm going to link it to the number 2. Now you'll notice that I have this text box here. It says A equals, and then this guy over here is actually an input box. And if I type something like pi and hit enter, it's going to change the value of A. So this is maybe a really, using just a number is maybe just a poor example of this. If I do something like f of x equals x squared, then I'm going to have a function, its graph is plotted right here. If you put another input box, I'm just going to title it f of x equals. If you link it to the object f of x, it's going to put a little input box, and it'll put the value of the function f, really just like the expression for the output. So now if you type something like cosine of x, it's going to change the function value. So this can be really, really nice if you have various things on the screen that you want to adjust, and you want to adjust them very precisely, or if you want to change the definition of something without having to go into like an algebra window and change it. You can put little input boxes on the screen to change values of different things, different objects. So this is something, I know I use it quite a bit. It's nice to be able to change different things. It's like before I had a slider for n for the number of segments. You could easily just have an input box and type however many you wanted in there. So those are pretty easy to make, and they're pretty handy to use. One thing, if you go to the object properties, there's a tab called style, and you can actually change the length of the input box. So you'll notice that this input box length went from 20, which is the length of this guy, to 10 over here. So if you wanted to make them smaller or bigger based on what you're using them for, you can do that through the object properties. So input boxes are pretty handy. What else do I have on my list? I apologize if I'm going fast. 2.5 hours is pretty short actually to try to explain everything GeoGebra can do, but I wanted to at least give you guys kind of like an overlay of all the various things you can do. So if you're ever creating something, if you're trying to do something, you'll at least know you can do it. And then when you know you can do it, you can either like Google it or email somebody like myself and I'll answer questions. But it's nice to just know like the really broad capabilities you can do with GeoGebra. There's a lot of times I talk to people and they're like, oh, I didn't know GeoGebra could do that. But there's a lot of things you can do. So I'm just trying to give you at least, maybe the big takeaway is not that you know how to do everything right away, but at least know some of the things you can do and know at least where to look if you want to try to do something. So now I'm going to talk a little bit about 3D graphics, because I think this is also a nice feature of GeoGebra. So if you go to the view, all I did was go up to the view menu and checked 3D graphics. It'll pull up a little 3D graphics window. And then if you click inside, you can drag around to rotate your view. So you can rotate this guy around if you want a better view. And then you can start to define various 3D objects. You'll notice that there's already something in the plane, which is really actually just the graph of f. So I talked about this a little bit on Tuesday. By default, GeoGebra is going to take everything that's in graphics 1 usually, and it's going to graph it in the XY plane of 3D graphics. And vice versa, if you have an object in 3D, anytime it sits in the XY plane, like if you have a point in 3D and it sits in the XY plane, it's actually going to plot the point in graphics 1 usually. The reason I say usually is because if you right-click on an object that sits in both, and you go to the object properties, in the advanced tab, there's a location bar, and you'll notice that it says graphics, graphics 2, and 3D graphics. So right now it's showing this object in both graphics 1 and 3D graphics. So maybe you say, I don't really want to show that in 3D graphics. It doesn't make sense for what I'm doing. You just uncheck that box and it won't show it in 3D graphics. So this is the same conversation goes if you have like graphics 1 and graphics 2, which are both like two-dimensional graphics. If you're doing two different things, like one on one side, one on the other. If you want to hide and show things relative to one screen, you just go to the object properties, go to advanced, and just click the checkbox you want, like where you want to show it. So now in this 3D guy, you can define various things. So there's a handful of different 3D commands. So for example, if you hit on the bottom right hand side of the applet, there's a little wedge in a box. That'll just pull up a list of, I think, all of the function GeoGebra has. I think they put every single function in there. And you can start to search the different commands. So here's all of the 3D specific commands GeoGebra has. So notice there's actually kind of a lot, I suppose. So you can easily create cones, cylinders, dodecahedrons. You can find heights of objects, octahedrons, nets of polygons, planes, spheres, a bunch of different 3D objects. They're pretty easy to create. You just do whatever the command is for them. So I'll show you one example of how easy it is to create things in 3D. So if you wanted to create a sphere in 3D, if you were using, say, graphing calculator, you would have to actually enter in the mathematical formulation of it. So you could use, spherical coordinates, you could do it relatively easy. Polar coordinates would be a little more challenging. Cartesian coordinates of a sphere is actually kind of hard. I think that's like a Calc 3 problem, probably. With GeoGebra, it kind of just does it for you, and you can kind of cheat the system a little bit. So I'm just going to define a sphere. So I'll just do S equals sphere. And we have a couple options. Point and point, which I don't usually use that one. I'm not sure if it's the center point and a point on the outside of the sphere. Or maybe it's 2 points that are both on the sphere. I usually go with the center point and the radius. So if my center point is 1, 0, 2 with a radius of 2, that's all I have to type. And GeoGebra is going to display a sphere in 3D graphics window for you. So now you can rotate this guy around. You can zoom in, zoom out. One thing you'll notice is there's this gray box that sits in the sits around the 3D graphics window. That thing is called clipping. It's pretty common in 3D software. What it does is it's just going to, anytime the object is outside of that box, it's just not going to display. It's going to clip it off. This is so that if you have an object that's really, really huge, it's not blocking the view of everything you have on the screen. So it's really, you kind of have to have it to some degree. But you'll start to notice that if your sphere goes outside of that box, it just gets rid of it. One thing you can do is, if you don't click on any objects, you just click in white space. You have a bar full of different options. It takes a little while to get used to what these are. You can actually click this one, and it'll hide that clipping, so it doesn't use the visible clipping. So now your object's you're gonna see your object until it's outside of the actual 3D graphics window itself. And then you can change various aspects of this thing, like maybe we'll make it green and a little bit see-through. And it's pretty easy to create things like this. So I use this fairly often for creating pretty simple 3D objects, like a candle burning. You can do that in 3D, or maybe you have a vase that's filling. I showed you a couple of those. Or if you have maybe just a cylindrical tank that's filling with water, you can do these pretty easily just using cylinders. It makes it a little easier to do, and you can do it a little more efficiently. So there's objects like this, like sphere, cylinder, cone, dodecahedron. Objects like that you can do pretty quickly. You can also create your own surfaces and curves. So like flashback to Calc 3, or maybe flash forward for some people, I suppose. You can actually create surfaces, which is really just functions from R2 to R3, or they're really just three-dimensional surfaces defined by two variables. So to do that, GeoGebra has a command called surface. So if you start to type surface, you'll notice that it has expression 1, expression 2, expression 3, parameter 1, start end, parameter 2, start end. So this is something like you give it an expression for x, y, and z in two variables. Usually it's u and v. It's pretty common in calculus. And then you tell it what you want your range of u to be and what you want your range of v to be. So I'm not going to go into this because it's actually gets kind of complicated if you want it to be complicated. But know that you can. I just lied to your face. I'm going to do a little bit just to show you what it does. So for example, you can tell it what you want the x-coordinate to be. So, and you don't need to do this because this is way too fast for you guys to pick up on what I'm doing. But you can give it expressions for x, y, and z. And then you tell it what your variables are. So u from 0 to 2 pi. And then it'll create this little surface. So this one's kind of weird because I just picked a random formula for this. But it'll create these 3D surfaces for you. So like in graphing calculator, you can do this, I think using u and v in graphing calculator. So it's kind of the same idea. Now you just have to use this command called surface, and you feed it x, y, z expressions, and then variables starting end value. So you can do surfaces in there, which is nice, especially if you're teaching something like three-dimensional calculus, various other things. You can also do curves in 3 space as well as 2 space. So there's a command called curve, and so to think about curves, in 2 space it's like you have one parameter, usually graphing calculator it's t, so it's kind of like this variable that's not on an axis. So in 2D it's like you imagine t increasing from 0 to 1 or 0 to 2 pi, whatever you want your thing to go, and then you tell it what you want the x and y coordinates to be for each t value. So if it's like cosine t sine t, and t goes from 0 to 2 pi, then really in 2 space you're tracing out a circle. 3D it's kind of the same idea for curves, but now you give it x, y, and z. So for example, if you did x value of cosine of t, y value of sine of t, and z value of t, and you let t go from 0 to 2 pi, it'll create this three-dimensional curve. So you can do curves and surfaces pretty easily. You just have to know that you're using a curve command and a surface command. And then you can start to do various things with this. Points in 3 space are pretty easy. They're basically points in 2 space, but you just give it a z coordinate. So if you do 1, 1, 1, you give it x, y, and z. It'll put a little point at coordinates 1, 1, 1. Once your point is in there, you can actually, if you just define a regular point, you can actually move the point around in 3D. You'll notice that as I hover over this, you guys notice the 4 arrows. So that's just saying it's going to move in the XY plane. So now when you click on it and drag it, the Z coordinate of this point actually doesn't change. You're just changing the XY coordinates. If you click on it again, it's going to go to these 2 arrows that look like they're going vertical. And then you can change just the Z coordinate of a point. Which is really nice because when trying to move things in 3D, which are actually just a 2D projection of 3D, things get really confusing, so it's nice to be able to control whether you're going X, Y, or just Z. And then you'll notice, so what I did here was I put the point P in the XY plane. So P is, GeoGebra sees it over here as a 3-dimensional point, but its Z coordinate is 0. So it's going to view it as also a point in 2 space. So it does this by default. Again, you can go into the object properties and turn this off, like don't show it in graphics 1. But if you don't do that, then you'll notice that you can actually drag it in either window. So if you drag it in graphics 1, it's just going to move around in the XY plane in the 3D. And as soon as you move him out of the XY plane, he's no longer in graphics 1. So some things you can do there. Any questions so far? All right, so that was pretty fast as well, but 3D is one of those things. There's not a ton of stuff you can do with it. Or GeoGebra, it's like a recent development for GeoGebra. They just started supporting it like a year ago. But it's pretty good stuff. I've explored some like Calc 3 based topics with it, which has been pretty cool. It's pretty easy to adjust visuals and stuff. And then you can have a nice interplay with the 2D graphics window if you're clever about it.
What is graphics 2?
Yes, let's talk about that. So graphics 2, so when you pull down the view menu, you notice that there's graphics, graphics 2, and then 3D graphics. So now I have 3 panes open. This guy's graphics 1, or I guess really just graphics. And then graphics 2 is over here. Graphics 2 is really just more or less a duplicate of graphics 1. I don't think that means what I wanted it to mean. It's really just another two-dimensional like plotting window. So you can use it exactly the way you'd use graphics 1, but now you have 2 different displays. So for example, you could plot a point in graphics 2, and now this point over here is in graphics 2, and you don't see it in graphics 1 by default. You can, though, if you go to the object properties, turn the location to graphics and graphics 2. And now it's going to show B in both windows. Yeah.
If you graph a point and you have both windows open, by default, which one does it appear in?
That's a great question. This took me some trial and error to figure out. I always wondered too. So right now, I'm in graphics 1 because I clicked in it. And you'll notice that this graphics word right here is bolded. That bolded means you're like pointers in graphics. All right, GeoGebra sees you as working in graphics. If you click over here in graphics 2, you'll notice that graphics 2 becomes bolded and not graphics. So it's going to put it in this active window, whatever one is bolded, by default. So yeah, if you start to do something like, right now my cursor's in graphics 2, so if I type C equals, I'm just going to define a point, by default it's going to put it in that graphics 2 window and not in graphics 1. So if you want to create a bunch of stuff in graphics 2, just make sure you first click in graphics 2 and make sure this thing's bolded, and then it'll start creating things in there. And then again, like I talked about last time, although like the point C is only in graphics 2, it's really thought of as like a global object. Any window in GeoGebra will recognize the object C. It knows it's there, you're just not displaying it in certain windows. So what I can do is, for example, if I click over to the graphics 1, I could create a point, I'm just going to call it D, and define it by C plus 1 comma 1. I'm just going to take C, translate it to the right one, up 1. So you'll notice that D is now in graphics 1, but it's defined in terms of C. And as you move C, D is updated accordingly. So these are really just kind of superficial ways of using that, but you can actually do a lot of really cool things with that. If I can find, yep. Let me pull up I guess I showed you the bottle problem last time too, but this is one way that I've found it pretty useful to do different things. So in one window I have like the actual scenario of something happening, and then if you, I can't see my volume. Oh, there we go. So then as you adjust, like right now I'm adjusting the cutout length, you'll notice that the scenario, it's increasing the cutout length. Then I have these little vectors on the axes that are representing the cutout length in inches and then the volume of the box in cubic inches. So there are a lot of cool things you can do with that in terms of like graphing in one window and then having something else happen in the other window. Other scenarios of this I can think of, even I've done recently, is like trigonometry. If you have like a circle in one window and then you're generating the graph of some trigonometric function, you can have the plot generating in another window. And then you don't have to worry about like fitting whatever you're creating to another window. And you can adjust graphics accordingly. So you could put a grid in one window and maybe change the background color to something like sky blue. I don't know. But it allows you to have two windows open, which is, it's actually pretty convenient to do some of these things. Once you start playing around with it, you can find a lot of nice uses of this. So that's what graphics 2 is. It's really just like another 2D graphing window so that you can actually have two of them, not just one. Any other particular questions? Are you wondering anything? I have about 15 minutes left, so I can talk about whatever you guys want. Yeah, Mark.
Maybe review what the choices for the tasks were.
Yes.
Do and give them a chance to start.
Well, yeah, that's a great idea.
To ask questions.
Yeah, that's a great idea. All right, so if you have the slide open, or if not, slides 44 and 45 are what we discussed last time for activities. And I can actually open these applets up if you want me to and show you how they're supposed to act. Unless you guys, or maybe you can interpret it from the slides. I tried to make them pretty descriptive in the slides. But so this first activity is, it's kind of in small view now. You have two segments, A and B, and they're both controlled by these draggable points. And then you want to have a sequence of tick marks that mark off however many segments you need so that you're like measuring A in units of B. If that makes sense. Do you guys want me to pull up this? Or have you guys looked at this at all? Okay. Did it make sense? Did anybody look at it and like wonder what was going on in my head? What I was like, were you confused at all? Okay. Yeah, I tried to make the instructions pretty descriptive. And then the other one was this circle with adjustable radius that has basically an arbitrary number of tick marks. You can choose how many units are in a full rotation. And that one actually makes use of the input box. So I don't think I talked about that last time. So that's something new that we did this time, where you can type in however many units you want to comprise the full rotation. Yeah?
The red line that goes, is that like a feature on here, or is that like not behind it? Yeah, there's a feature. There is. Okay. Think about like what it is that you're trying to make. I found like the angle. Yeah, okay, but like what's that segment called? Arc, right? There. That's how I found it. Okay. Just make sure it's turned on once we find it.
Yeah, so that GeoGebra has some built-in things. You could also do that parametrically. Or these, like if you find the GeoGebra feature, there's some commands in there that can do it too.
minutes to get started on that, and then Grant will stick around and answer questions. I can try to help, but it might help.
What did you do?
It's up on the slider checkbox button. Yeah, it's like the
The wheels are going the wrong way though.
Oh, I'm making.
Now they're going the right way. They need to rotate clockwise. It moves to the right.
I love this.
Your wheels are going the wrong way though. Too.
Ah, you see, I had it right. You lied to me.
No, I did it.
Look,
Now they are.
Part of it, I was so
oh,
attached
what's
to
wrong with it?
the thinking behind graphic design. But it was a
Oh,
little
okay.
bit like jarring to switch to object oriented.
Weird, it like switches halfway.
That's because the slider depends on this A.
Oh, the slider is changing. Oh, that's easy to fix. I'm just gonna hand the slider this way. Okay, and so the obvious question comes up about your projects. Can you use GeoGebra? So here's what we'll do. So you're required to use GC. We'll say 2. So we got 2 objects in GC, and then GeoGebra is optional. If you want to also use GeoGebra, you're welcome to do that. But GC required, GeoGebra optional for your project. Or one really, really good one. Yeah. And yeah, it's doing a lot of stuff. And, yeah. But yeah, you gotta have GC in your project.
I figured out most of it last time. You know what took me forever was figuring out how to get this, how to keep this moving on a straight line. But then I realized there's 2 segments. There's an invisible segment that point is on. So you'll notice there's a limitation to how far it's going to go. And it's limited to that's the limit of the invisible segment.
You're gonna be able to change that. I think their web version is kind of they've done all the
If I were to basically the same.
Like copy and paste.
Yeah.
Just save as. You get a new file.
Oh, okay.
Sure.
Okay.
So, yeah, just save, so save as. And this some new file name, you'll have 2 identical files.
I should try that
Yes.
evil one.
But no, you can. I've tried to do that too. Like if you want to scroll through like 2 or 3 dots.
I like the measuring stick one
Well, thank you.
I think that'd be really good for helping
Oh,
students
this is
with that
what we
idea
did.
that
This is what we did
dividing measuring one thing
in
and
skip.
Oh, okay.
That doesn't
I
go.
think so.
Yeah.
It's quite useful.
Yeah, and then did you also do?
I haven't done the other one before.
Oh yeah. Yeah, it's still not necessary, and I usually, by default, it's not one of the go-to making, but I started to do a little bit lately. Sometimes it's nice just because you don't have to have cosine design.
Yeah.
I shorten it up a little bit. Works mostly. I figured we'll do the same things. Yeah, that's something I only thought of that because somebody I work with was like, we did this before. I was like,
Silly practical.
yeah, and GeoGebra also has computer algebra, watered down version, which can do some interesting things
I did the clinical
like
one.
factoring, expanding, triples, circles,
Why am I not
which is sometimes kind of nice. I use it for stuff. Mostly stuff you can probably do in GC, but
Practical implications.
so things like you can do indefinite intervals, like simple ones, like execute square plus c, things like that.
Yeah, I know that that's part of the appendix, but why do you have to have so many columns?
But I didn't really this off my touch, I just made sure that I had the right same just
Yeah, once you get used to sequences of there, it's gonna be a lot of really cool things.
How do I fix rotation?
Oh. What are you guys doing?
Just keep great. I knew you were gonna say it. Thank you.
Yeah.
Because originally what I had was a sequence of points, and then I reflected them over I was trying to figure out how to connect. I realized, hey, wait, that doesn't work.
Yeah.
Don't do that.
Yeah, so then you just.
So then I was like, oh, well, this is way easier. And I just got the code.
Oh, you want I'll take it.
Yeah, actually, here's my other question. How do I get the little markings?
I don't know if I can actually just do like Wi-Fi.
But like,
So this is basically
I
Yeah.
don't know.
Another fun,
Yes, the other side.
good task is
I wish I
to
could zoom in and
display
I don't have my
measures.
No, I'm not doing it.
Which it's a little more challenging, but
Can't hear
when I do
barely.
it, it's like for trig stuff, I just
I'm trying to change.
take like
Holy moly, so tiny.
I'll figure that out.
Which one is in the rotation T? Is T? Is this one? This one, right?
Yeah. Yeah.
Oh, yes.
Well, I'm really
Yeah, there's a handful of ways, but actually,
it's like
you can actually,
that was my
you have to, yeah, like, it'll give you
That is awesome.
Yeah.
That's so smart.
Yeah, and then it'll put back, and I think by default, you can change whether. So there's actually a handful of things, that'll take the article as much.
I was bored.
You're always bored.
So you want your bike to go from 0 to 2 high, and then
Oh, I
you
was
have
wondering about those things. The other way to do it is
high,
the
and then the next rotation will go from 2 high to 0. So
So
you're gonna have your straight
like that.
Oh.
However many.
I mean, you can do more if you like add
That's how I
more periods to it, but if you want to do one period, just start it from 0. Just start like the back one from 0. It actually is after. Yeah, do it from 0
Oh,
to
because
high.
it's gonna start turning like very quick.
Because I don't want to spend
I can spare next week.
which ones?
Spectrum.
Last summer. There was a really chill
All I had to do was move the screen. You know, I'm sure you did that.
And I don't actually like it. I didn't like MTE250 lines in blue and it's a
Yeah.
like it was associated with red. Yeah, I thought okay.
I didn't do
Yeah, I didn't know about font, but I figured. We can do green if you want. Okay, you're green now. But Exactly. So I mean, yeah.
I have a meeting at 3, so I might not do it.
Our project,
Okay, so now we can.
we have kind of like one just GC file that does everything. I didn't know if it was.
Yeah.
No.
No.
Oh, okay.
I mean,
I have two, because there's one where our sine, cosine,
So-
graph, in terms of the reason, like, or something somewhere. And then we have one where it stays constantly at 1. One that is like reasons highlight that. So there's
By the way,
I thought I did it right. Yeah, like,
they're sitting there as a white
you can
board.
change whether or not like
Well, if you do want to base it
yeah, it was basically just
yeah.
like
So
this.
it's not much
from 0 to n by 1, 0, 0, 1.
So instead of 1 to 10, it's like,
Or what do you want it to be? 1? First of all, you have to have 6 points. So I will be that point. Okay, and then I
yes, I do have the sliders on for tonight.
So I went in and I think around the
Oh, right, right.
ah,
I